500 million years ago. The microcontinent was situated near the equator. The Western scientists called it Kazakhstania. The structure with almost full list of elements from the Mendeleev's table inside its depth. What secrets does Kazakhstan soil have? How rich is it? Natural resources are the history of our land for thousands of years.
Today on the program, red beginning of white, turning bauxite into aluminum. Pavlodar aluminum plant, the aluminum flagship plant of the country. Kergetas, the largest limestone quarry of Kazakhstan. How do you think? What do this spoon, ring with a ruby and a piece of brick color ore have in common? All of them, different in shape, color, price, and designation, have aluminum oxide in their content. This alloy name is corundum. Big, transparent crystals of corundum are used as precious stones. Due to some admixtures, the mineral can have different colors. Red corundum containing chrome is a ruby, while blue one with titan and iron is traditionally called sapphire. But the highest content of aluminum oxide is in aluminum ore, of course. This is bauxite, a complex subsurface rock. It contains aluminum hydroxides that actually form the core ore mass. It also includes oxides, iron silicates, and aluminum minerals. Bauxite is the main raw material used to produce well-known metal aluminum, which spoons are made of.
Глинозем вообще это очень интересный продукт. Его химическая формула алюминия 2O3, но на самом деле...
Alumina is an interesting product. Its chemical formula is aluminum oxide, or Al2O3. But as a matter of fact, the physical properties of alumina are caused by its crystalline structure. And here the situation is the same as with carbon, which everybody knows. So what is carbon? It is coal in the first place. Coal is carbon in general understanding. Actually, carbon exists in different modifications of crystalline grid. Let's take graphite as an example. Slate pencils we use contain carbon which has certain crystalline structure. If taken coal, it is not crystalline structure. It is carbon containing some admixtures. And the prominent material, which is the hardest material on Earth, or diamond, is carbon, but with particular structure of crystal. The same situation is with alumina. Aluminium oxide can be called alumina and corundum, and it is such well-known precious stone as ruby.
И это всем известный такой драгоценный камень, как рубин.
Kazakhstan is the second country after Russia in terms of bauxite reserves among the CIS countries. The projected resources of our country are estimated at 800 million tons. Today there are two large deposits containing aluminum ores in the country. The open-pit mining method is used here, and both deposits are situated in Kostanay region. One of them is Torgay mine, where bauxites belonging to East Torgay group are mined. The second one is Krasnooktabursky bauxite deposits, where bauxites of Western Torgay group are developed. These deposits were discovered in the 50s of the last century. It is important to mention that initially the discovered reserves could not be developed. According to its chemical content, Kazakhstan bauxites were not fit to be processed in industrial scale. However, after a while the scientists developed a special technology for the homeland bauxites. But first things go first, and in the meantime, the extracted bauxite is shipped by train from Kostanay to Pavlodar region, where metallurgists use this heap of red color ore to produce alumina. The Pavlodar aluminum plant is one of the oldest plants. and it is the only one in the country to produce alumina.
История нашего предприятия начинается с сентября 1955 года.
The history of our plant started in September 1955. During this period, the USSR Ministers' Council issued a decree saying a decision was made to build an alumina plant in the Pavlodar region. In 1960, the All-Union Aluminum and Magnesium Institute developed the project with a capacity of 600 tons of alumina per year. In 1964, the first stage was launched, and during the next 5 years, the second and the third stages were launched to ramp up the production up to 1 million ton.
Наращивание мощностей до 1 миллиона тонн.
Due to having such high growth rate, the plant was honored with the highest award of the USSR, winning Red Banner of Labor Award in 1971. However, during the period of the Soviet Union collapse, this plant, as well as many others, was going through hard times. But it managed to keep the most important thing, which is a team of well-experienced specialists. In the times of independent Kazakhstan, the industrial giant got its second life owing to new investors. In 1994, Eurasian Group LLP was established to manage the aluminum plant, thermal power station number 1, and 4 bauxite deposits.
В 1994 году Павлодарский алюминиевый завод перешел под управление инвесторов и НРС.
In 1994, the ENRC investors started to manage the Pavlodar aluminum plant, and in 1995, it was reorganized to become Kazakhstan Aluminum GSC. The first problem which the investors faced was depletion of projected bauxite reserves of Turgay deposit. I would say a lot of funds was invested. A lot of unique schemes to process low-grade bauxites were developed, and as a result, it helped us not only to keep the ongoing production capacity, but also to increase it till 1.5 million tons per year.
Ну и нарастить ее до 1,5 миллиона тонн в год.
Today, the plant belongs to Kazakhstan Aluminum GSC and enters the top 10 largest plants producing alumina. During the last 25 years, the plant produced near 60 million tons of alumina. The projected capacity is 1.5 million tons per year. Bauxite extracted at all mines is brought here into the blending facility of raw materials preparation. In order to obtain alumina of high quality, they prepare ore thoroughly before putting into the process. Here the ore is crushed into fractions of needed parameters and put into stacks, each weighing 30,000 tons.
Бокситы у нас приходят с 4 рудников. Это Аятский рудник, Белинский боксит.
We receive bauxites from 4 deposits. They're Ayatsky, Belinsky, Krasnogorsky, and Turgaysky deposits. They have different content if talking about their structure. We extract silicon module depending on the obtained raw materials. In other words, all of these red color heaps are not just disorganized piles of bauxites. This gigantic 360-ton bucket wheel excavator takes ore masses delivered from a quarry, mixes them with others and put into stacks. Thus, now bauxites have blended content of all elements. The stacker processes 10,000 tons of ores per day. In addition, the unit of raw materials preparation not only forms the obtained ore, but also provides storage space for bauxite reserves in case of any failure in transportation or other emergency. In general, this storage allows to keep up to 400,000 tons of bauxites in its reserve. The sintering unit is the first stage of ores blending. On the whole, the unit of raw materials preparation consists of 2 sections. The first section is designed to receive delivered raw materials to crush them in accordance with the predefined parameters. Bauxite is crushed into pieces of 100 millimeters each, coal and limestone 40 millimeters. The second section is used to put blended bauxite to the hydrometallurgical unit and sintering unit. 6,500 tons of bauxite are needed to produce 2,000 tons of alumina, which in its turn is used to get 1,000 tons of aluminum. The Pavlodar aluminum plant applies a unique method of processing bauxites with low content of useful components. The thing is that globally such plants use Bayer technique to produce alumina. But this method is more likely to fit for production of rich ores. The technique is about leaching previously crushed bauxites and further separating aluminum hydroxide from the solution. After absorbing hydroxide, the gravel can be easily separated. It is called red mud. Other countries widely practice processing of high-quality bauxites. There, red mud is considered as waste that should be disposed. In our case, red mud is processed, and useful components are extracted during the sintering stage. It is the sintering method which Pavlodar metallurgists use to extract aluminum from mass that are about to be disposed. Red mud, containing 22–23% of aluminum, is delivered to the sintering unit. In the sintering unit, more valuable components are extracted, and only 4–4.3% of aluminum remains in wasted sludge. Such way of double-stage alumina extraction is called Bayer parallel serial method of sintering, which is applied only at the Pavlodar aluminum plant. The raw material sintered in furnaces is multi-component mixture. It consists of red mud, obtained in hydrometallurgical unit, limestone, sodium carbonate, reducing coal, and bauxite. By the way, all of these components of mud are supplied by Kazakhstan companies. Earlier the plant used coal delivered from Kuzbas, but since 2000, the raw materials from Shubar coal deposit have been brought here. Another component which is needed to produce alumina is limestone. Limestone plays an important role in the technological process of alumina production, as it binds parasitic components from bauxite. It is silicon oxide and iron oxide. It binds them into insoluble compounds and takes them out of the technological process. This is the well-known limestone mine, Kyrgyzstan. Today this deposit is highly advanced enterprise. The main technological process is mining of limestone, as well as transportation, crushing into fractions, and delivery to consumers.
Изучение месторождения известника Киргизского началось еще, история его началась в конце 19 века. Систематическое изучение.
Studying of the Kyrgyzstan limestone deposit and its history began in the end of the 19th century. The deeper research started in the 20s of the last century, and between 1958 and 1961 they conducted large-scale geological and exploration works. As a result, in 1961, geological reserves were registered for the Kazakh SSR. By the present moment, at the Kyrgyzstan mine, which was launched in 1966, near 79 million tons of limestone were extracted here. The deposit itself is a formation of limestone from 200 to 700 meters wide and up to 6 kilometers long, going towards northwestern direction. The Kyrgyzstan quarry is located in the Bayanulsky district, 150 kilometers away from Pavlodar. Over 50 years, the mine has been supplying necessary raw materials to the aluminum plant. In addition, the Kyrgyzstan limestone is transported to the Aktabe plant of ferrous alloys. Also, this mineral is used to produce lime and building stone. The guaranteed term of development for the Kyrgyzstan deposit reserves is 70 years. This is a unique deposit with such a low index of overburden and such a rich content of valuable components. Thus, at the present moment, the content of KCO3 is over 54%, while the level of harmful admixtures is around 2%. This mine is a unique deposit. There is no limestone of such quality in any other area of Kazakhstan territory. According to the conclusions of experts, the quality and volume of minerals exceed all norms and standards. Based on the specialist's opinion, this volume of limestone will be enough to process all Kazakhstan bauxites.
Месторождение образовалось в ордовийской системе.
The deposit was formed during the Ordovician system, or over 350 million years ago. This is a sedimentary deposit formed as a result of sedimentation. Here was an ancient ocean. As a result, the ocean went away and came back, so there was sedimentation of organics. Here you can see shells and ancient mollusks in limestone. It means this is an organic compound.
Органическое соединение.
The estimated capacity is 2 million tons per year. But in case of necessity, the production can be increased up to 5 million, the miners say. Near 300 people work at the mine. The daily extracted volume can reach 7 tons of limestone. In the quarry, the blasting works are conducted 3 times per month in average. One detonation made in the mine helps to release near 60,000 tons of rocks. The process of preparation for one of the key stages of the limestone extraction is carried out very thoroughly. There is no place for mistakes here in terms of grams, centimeters, or seconds. After the blasts, the excavators are put into work, followed by dump trucks that transport the extracted rock to the crushing unit. And then the limestone will be sent to consumers. Over 80% of the extracted raw materials are shipped to the Pavlodar aluminum plant. There are almost 70 wagons sent daily. All of the raw materials brought to the plant warehouses are thoroughly checked. That is why there is a central laboratory operating in the territory of the plant. The quality check is permanently made in all units of the plant. The Department of Technical Control performs an entry control of bauxites coming to the plant, as well as limestone, coal, carbonate, soda, such kind of materials. The central laboratory includes many smaller laboratories, one part of which is located in the central building where we are at the moment. Some of them are distributed among the key facilities. In the facilities, our specialists control the processed products. There are liquid and solid fractures of semi-products. It helps to track technological processes and implement them correctly, which affects the quality of released products in the result. The equipment which helps to control the quality of released products is concentrated in the central building of the laboratory. There the specialists study the content of admixtures in the produced alumina, the content of aluminum oxide, and other parameters of the products.
Нужно отметить, что центральная заводская...
It is important to mention that the Central Plant Laboratory is a certified laboratory. It means we have undergone the approval procedure, which increases the level of trust towards our laboratory and indirectly confirms that the results of produced alumina quality check we make are reliable.
Нельзя сказать, что... это все понимают.
It is worthy of note that any plant or factory producing any kind of materials has some defected goods, but our goal is to prevent any defected products from leaving the plant. As a matter of fact, owing to this, our laboratory controls the most advanced technological processes, and the results of our interim analysis show that all of the processes are corrected in such a way so that produced alumina has needed content and mark. Thus, the first stage of alumina quality control is the control over technological processes. So, after undergoing the laboratory control, the components should go through a complicated technological procedure. Alumina is extracted in 2 planned lines. The material put into these furnaces and other reservoirs of the hydrometallurgical unit is hard to be called alumina. All of the stages are automated. Each line has computerized control units used by metallurgists to control the process.
Технологический процесс печной нитки с
The technological process, based on agglomeration technique, is fully automated.
печной нитки
There is an agglomerant on each line of the agglomeration line to control the process.
агломерат
Also, the operations of agglomerants are controlled by the unit operator, who controls all technological parameters of the processes. He also controls chemical analysis of the received raw materials, as well as the working process of all units where raw materials are delivered.
поставщиками
He also controls work and makes prompt decisions related to changes in technological parameters of all the technological processes execution. In the result of using bare parallel serial mode of agglomeration, aluminate solution is produced here. After the post-filtration stage, the aluminate solutions are cooled down to 50–75 degrees Celsius and sent to decomposition stage, which is crystallization of aluminum hydroxide under certain chemical conditions. Decomposition is the most important stage of alumina production, as the quality of alumina directly depends on physical and chemical properties of produced aluminum hydroxide. And production capacity of this stage defines economy of the whole alumina production.
Мы контролируем выпускаемый гидрат уже, скажем так, досконально.
We control produced aluminum hydroxide in terms of all parameters according to which alumina should be controlled.
Основного
This is the content of the main product, admixture elements, size of fractions, which also indicates the product quality.
тоже является показателем качества.
The next stage is transportation and calcination of aluminum hydroxide. The final stage of all technological schemes of alumina production is calcination. Its aim is to transfer input aluminum hydroxide into ready-to-go product, which is metallurgical alumina for electrolytic production of aluminum, and non-metallurgical alumina used in different industries, including electrical engineering and ceramics production.
В наш участок поступает гидроокись алюминия, гидрат. Наш участок
We receive aluminum hydroxide to our unit. We extract water and harmful admixtures from hydrate and output final product, which is alumina.
глинозема. Гидрат поступает в начале бункера, потом
The hydrate is firstly placed into reservoirs and then poured to burden by means of special dosing device. Here we regulate the upload and check the temperature, as each burden should have its own regime. We keep particular temperature in order to produce high-quality alumina.
глинозем.
The whole process takes place in these furnaces. They are divided into 4 sections. The first section is drying section, where water is evaporated out of aluminum hydroxide, and the temperature of material does not exceed 200 degrees. Then, in the calcination section, chemically bonded water is removed, so that hydroxide passes into waterless state. Here the material temperature is 950 Celsius degrees. The third section is ignition section, which is located in the zone of burning torch, which provides the highest temperature of gases, 1400 Celsius degrees. Thus the burden can be heated up to 1250 Celsius degrees. And these very parameters provide modification of alumina from one state to another. Cooling section is the final stage of the calcination. Here the final alumina will be cooled down till 1000 degrees. Here is alumina, the final product of the Pavlodar aluminum plant. It is hard to believe that recently, white crystal powder was part of red mud. And it is even harder to imagine that in a while, this powder substance will be formed into white, shiny bars of aluminum and will once become an airplane wing or chocolate candy wrapper.